Let's do section 10.8 in chapter 10, Flow and Conduits. This section is going to describe how we calculate the minor loss coefficient. That's going to be given the value of capital K. We'll find out that this is, again, a dimensionless number, and we'll describe how to basically determine this value and apply it to get the combined head loss. Remember that the major head loss is the pipe, the loss in the pipe, the head loss in the pipe, and the minor head loss is the head loss due to all the components. So we're going to need a strategy for determining head loss in bends and tees and so forth. So that's really the topic of this section. So let's go ahead and flip forward and determine what we're going to do here. So it's quite a long chapter. So this describes how to calculate head loss in components, valves, bends, and so forth. And the first thing is to define the pi group called the minor head loss. It's given this value K. And it can be interpreted in one of two ways. It's either the change in the head loss over the velocity head, v squared over 2g, or the change in piezometric pressure over the kinetic pressure. And so we can basically solve this equation now for the head loss, the minor head loss, and it's just going to be the value of K times v squared over 2g, where again v is the mean velocity. So the question then is, how do we find K for a given component? And the bottom line is, you use this table. We can see that there are various things. It's a little hard, but in the book you can see that we've got a pipe entrance, contraction, an expansion, a 90-degree right angle turn, a 90-degree smooth bend, and then threaded pipe fittings. And these all have K values over here. They're also sometimes dependent on dimensions, like the diameters of various sections. And so we just basically determine what sort of situation we have, what the dimensions are, come onto the table, and grab the appropriate K value and use that in the equation for the total head loss, or at least the head loss for the components. We would plug K into this equation right here to find the minor head loss, and we would combine that with the other stuff that we've done in the sections before to determine the friction factor and the major head loss, and that will give us the total head loss. So it's pretty easy to do. To apply this equation, you use the same approaches that we are using for pipes. We're going to be looking to classify the flow and also to look for the necessary equations, whether they be the energy, Darcy-Weisbach formula, flow rate formula, or what. And we'll be working some examples in class to look at these. You can see in this particular example, we have two smooth bends here, and so we would have to have two of these components added together because you can see the formula has the sum. You must sum up all the components and all of the different lengths of pipe in order to get the total head loss. So that's it. Pretty easy, pretty straightforward, and for what we're doing, the statement of the problem will have to direct you to the appropriate place on this table to determine your K values, whatever they might be. Okay, thanks.